The Keyright Company, a unique approach to quality cable manufacturing. In 1866, Austin Goodyear Day developed the unique insulating compound, Keyright. Since that time, Keyright has provided cable of the highest reliability. From the building of the telegraph and railroad to today's nuclear power plants, Keyright cable excels under the most extreme operating conditions. Producing a wide range of cables from 600 volts to 138,000 volts, Keyright's history of outstanding success results from the unique combination of superior materials and design, coupled with care and skill in manufacture. Keyright's on-site research and test laboratories and outdoor proving grounds assure the continued development of materials and manufacturing techniques to meet new challenges. Checkpoints at key manufacturing steps maintain and assure quality by feeding corrective information back into the process while also providing customer documentation. Consistent, verifiable, and traceable materials are assured by lot identification and 100% batch testing of compounded materials prior to their use. The Banbury thoroughly mixes these raw materials. On release from the Banbury, batch temperature is monitored to be certain it is within the specified range to prevent premature curing. Keyright's 100% batch testing, the most stringent in the industry, assures that all specified performance characteristics have been achieved before committing any compound to production. Precise fingerprinting is achieved by testing for specific gravity, cure rate, and viscosity at extrusion temperature. All insulation materials are then forced through a 100 mesh screen, fine enough to hold water. Each screen is then examined for possible contaminants and for complete dispersion of all ingredients. Process control is critical to consistent production of quality cables. During extrusion of Keyright's PermaShield layer, stringent production standards are maintained. PermaShield has insulating as well as stress control properties. For this reason, only Keyright verifies this important insulation system component with a 1 kV DC spark test. Laser micrometers continuously monitor, control, and record extrusion diameters over the entire length of all manufactured cables. Each CV operator is responsible for the quality of his production and is authorized to shut down the line. To confirm correct wall thickness, he measures and records these dimensions at each cutting length, and samples are held until the cables have cleared final inspection. To verify correct processing conditions, physical tests are performed on samples cut from the cured insulation of each production run. Electrical and physical examination of all conductors and testing of samples at this early stage of production ensures compliance with exacting Keyright standards. All insulated conductors are checked for wall thickness, concentricity, strand count, and conductor diameter. When specified by customers, water tank testing subjects full reels to 24-hour immersion before applying AC and DC test voltages and taking insulation resistance measurements. During the production and inspection process, test reports compile a record of all tests, inspections, and manufacturing data. Verification and traceability of materials is thus assured. Following extrusion of the insulation shield, concentric wires or metal tapes are applied. Keyright offers a wide range of jacketing options, including vulcanized jackets and thermoplastic jackets with the option of marker stripes for positive field identification. When requested, Keyright can provide full lead sheathing on all cables. Keyright also provides interlocked armored cables in a wide range of sizes, as well as submarine finished cables which can utilize Keyright's on-size splice to achieve cables in continuous long lengths. All finished cables are final tested on shipping reels and inspected under both AC and DC voltages to verify that insulation resistance, conductor resistance, and all dimension standards have been achieved and maintained during manufacturing. Evaluation of the physical characteristics of all cables is achieved by testing samples of each shipment. On request from customers, Keyright provides a certified documentation package that includes a certificate of compliance with specifications and all preliminary test sheets, cabling records, all physical testing data, and the final inspection report. Safe, reliable, and enduring, Keyright can design and manufacture for any environment, from direct burial to downhole to underwater. For electric power utilities, public transportation, petrochemicals, or offshore drilling and other rigorous applications, Keyright cables provide superior reliability. No matter what your cable needs may be, Keyright can design and manufacture long-life cable for your requirements. The Keyright Company's continued dedication to cable research and the highest quality manufacturing has made a vital contribution to our nation's electrification.
Keyright submarine capabilities. When faced with the challenges of providing safe, reliable electric power delivery across broad expanses of deep water, utilities and oil companies alike recognize Keyright as the premier supplier of submarine power cable and turnkey installation services. These types of projects involve a myriad of additional requirements other than just the cable alone. Before any cable can even begin to be constructed, installation permits, agency approvals, environmental concerns, and safety awareness must all be thoroughly addressed and resolved. This preparation and attention to detail is the basis for the overall coordination of the numerous necessary subcontracting operations which assure on-time project completion within budget. Off the coast of California in the Santa Barbara Channel, Exxon Company USA operates the Hondo platform, which draws its electrical power from a tanker moored nearby. In planning 2 new deep-water platforms in this Santa Ynez field, Exxon chose to supply the power for all 3 platforms from their environmentally conscious Las Flores Canyon cogeneration plant. This would require the largest solid dielectric submarine cable lay in the history of the offshore oil industry. This expansion required 5 continuous long-length submarine cables to be installed, 3 from shore to platforms, and 2 from platform to platform. Cables designated A and B, both 10 1/2 miles in length, run from shore to the Harmony platform, while the longest, cable C, runs 17 miles to the Heritage platform. Cable D, measuring 4 miles, links the Hondo platform to Harmony, while cable E stretches over 7 miles, joining Harmony and Heritage, completing the offshore to onshore power delivery connection. Although Keyright has over a century of experience in the design, manufacture, and installation of long-length submarine cables, the magnitude of this project necessitated the formation of a joint alliance. Keyright chose Coflexip and Services Incorporated of Texas and France for this venture. Coflexip, a leading manufacturer of flexible pipe, is known worldwide for its installation service capabilities. An obvious choice for this project, Coflexip was able to build upon their vast knowledge of deep water installations, easily adapting their expertise to electrical power cable. The three-conductor cables are all copper and rated at 35,000 volts, ranging in sizes from 4/0 AWG to 500 and 750 kc mil. With over 150 miles of single conductors required, the manufacturing time spanned 18 months. The cables were designed and produced at Keyright in Seymour, Connecticut, utilizing Keyright's proprietary rubber insulation system. This unique system incorporates PermaShield, an exclusive non-conducting energy suppression layer, and a specially formulated, highly discharge-resistant EPR-based insulation that maintains its original dielectric strength when tested even after decades of service. Upon completion of the individually jacketed single conductors, they were packaged in containers and shipped to Latreille, France for final assembly. Here at the Coflexip facility, the conductors were loaded into a mammoth cabling machine specifically designed for the splicing, twisting, and armoring of the record-setting cables. The key to manufacturing these submarine cables was Keyright's on-size vulcanized splice, a patented technique that joins the individual insulated conductors, enabling the production of continuous long-length cables. Skilled and certified technician teams from Keyright performed each splice. The insulated single conductors are stepped back to their bare conductors. A butt weld is then made, joining two conductors. An X-ray of the joint is then taken to ensure the integrity of the welded connection. Upon inspection approval, insulation materials identical to the power cable itself are then applied and cured. Each vulcanized splice is then fully qualified by another X-ray test, ensuring it either meets or exceeds the electrical requirements of the actual cable. This patented technique forms a smooth, homogeneous bond, creating a single linear cable diameter that, when completed, is no more than 5% greater in diameter than the unspliced cable sections, thus eliminating the possibility of installation problems associated with bulky, rigid, oversized field splices. The spliced conductors were then cabled with polypropylene fillers and a binder tape. A full layer of individual polyethylene jacketed galvanized steel armor wires was then applied over the core to provide mechanical protection. As each cable was manufactured to the specified length, it was tested and inspected under both AC and DC voltages to verify the specification compliance of both electrical and physical properties. The cables were then carefully laid into two stationary onshore baskets for storage until all 5 cables were completed. At that time, the finished cables were paid out of the baskets and transferred to similar baskets on board the lay vessel FlexService 3. This 250-foot vessel was specially configured and equipped with dynamic positioning equipment in order to ensure that the cables would be laid within plus or minus 10 feet of the intended installation paths. As the length and weight of the cables approached the capacity limitations of FlexService 3, precise weight and load placement calculations became critical so as not to affect the stability and trim of the vessel during ocean crossing. Departing from Latreille, France, FlexService 3 sailed down the Seine River, westward toward the Azores. Once into the waters of the Caribbean, she passed through the Panama Canal, up the west coast of Mexico, to arrive on schedule in the Santa Barbara Channel. In California, FlexService 3 took aboard specialized crews and equipment, ranging from remote operating vehicles, ROVs, and their pilots, to project engineers and safety inspectors. With environmental permits in hand and deteriorating weather conditions quickly approaching, FlexService 3 was now ready to begin the most crucial phase of the project, cable installation. The first cable to be laid was Cable D between the Harmony and Hondo platforms. The shortest of the cables to be installed, Cable D was pulled from the basket of FlexService 3 up a 1,000-foot J-tube on the Harmony jacket to a temporary connection. In order to monitor the cable pull and its placement on the seabed, the deep water necessitated the use of an ROV to act as the installation team's eyes. Once the touchdown point of the cable was identified by the ROV pilot, FlexService 3 began paying out Cable D while slowly moving toward the Hondo platform. When the lay vessel reached Hondo, the cable was paid out in a similar fashion. However, it was pulled up an I-tube instead of a J-tube. With the second end of Cable D secured, FlexService 3 sailed toward Harmony to begin the installation of Cable A from there to shore. Meanwhile, dynamic positioning operators were able to provide precise control of the ship's position, utilizing electronic beacons that had been placed on shore during pre-installation site survey work. In addition to Cable A, Cables B and C were also laid from the platforms to shore. The shore end of each of these pulls was floated by buoys as the cables were pulled through pre-installed conduits. These conduits extended over 1,100 feet from shore through a tunnel under Highway 101 into a trench approximately 90 feet to a splice pit. Here the cables were spliced to previously installed land cables, which extended from Exxon's Las Flores Canyon substation. As during manufacture, Keyright engineers and technicians again tested and documented each and every cable during installation. These records verified the integrity of the installed cable while providing baseline information for future inspection and potential maintenance. Since the permanent decks have yet to be installed on Heritage and Harmony, steel cable protectors were put in place over the cables until final connection to the switchgear can be made. The largest solid dielectric cable lay known to the offshore oil industry, over 50 miles of cable, successfully designed, manufactured, installed, terminated, and tested, both on time and within budget. From offshore divers to onshore operating engineers, this historic engineering achievement was an international team effort that met the challenges of the project head-on with technical skill and unprecedented cooperation. Keyright submarine capabilities, the total solution to your underwater power delivery needs.
That screwy valley, hooey Hollywood, where any office boy or young mechanic can be a panic.
All right, let's have some lights, please.
I'm filming Tim.
Number one, we wanted the finest cable produced in the world. Keyright makes great cable. We wanted a cable company to offer its expertise when it came to designing our duct bank layout. We wanted a cable company that would offer the right solutions to those problems that come up during cable pulling to ensure a smooth installation process. Keyright's been there 1,000 times on 1,000 jobs. They have the know-how. Keyright offered Paramount
Engineering assistance. Cable specifications. Loading and sizing. Duct routing. Bolt preparations and locations. Cable pulling. Splicing and termination. Fireproofing.
We've got the map of the lot up on the screen right here. We're going to have a 90 here, here, and here. How's that look, Tim?
Well, these 90s reduce our pulling lengths and add sidewall bearing pressure. By putting sweeps in, will give us longer runs, reduce the number of splices. You think you can get the sweeps in, Lonnie?
Yeah, sweeps would be a lot better, Mark. You'd have less wall bearing pressure and be a cost saving to do away with those splices.
Great, let's do it. The plan that we have for the circuit is to run parallel 500 MCMs in 5-inch conduit. Well, that presents us with a problem because we have too many conduits now in our duct bank and we have a duration problem. What do you suggest?
I would suggest that we look at doing 2 parallel 1,000,000 kV cable, and I brought along a sample of that, which is this cable right here that we can pull into your system. Not only can we pull it into your 5-inch, but because of the way it's manufactured and it's 100% insulation level, we can pull this into your 4-inch that you have in your existing, which means you're not going to have to tear out your existing system to expand your...
We can reuse the 4-inch conduit?
Yes.
That's fantastic. That'll save us over $250,000 in trenching and insulation cost alone.
Yes, and we can pull this by triplexing it. We can make this in your runs, and we have reviewed that. And it will be very easy to make that pull.
Final details are discussed. The overall plan is reviewed, and scheduling is locked in. And now it's time for on-site work to begin.
The primary concern of an active motion picture studio like Paramount Pictures in Hollywood is always going to be the necessity to keep all aspects of the facility that affect the production of motion pictures and television operating without interruption. Any delays cost a great deal of money for each show affected. Aware that Paramount required assurance that production would in no way be disrupted due to the introduction of heavy equipment, trenching, vault excavation, deliveries of construction and electrical materials, as well as the actual cable pull, Keyright offered their on-site expertise to help the studio avoid problems. Working closely with Keyright, Paramount knew in advance exactly where the introduction of new cabling and ducts would require open trenches and pits, as well as when heavy equipment would be needed during the operation. As a result, the studio was able to prepare itself before work began. Keyright's cooperation with Paramount and its other contractors enabled the electrical upgrade operations to proceed without any interruption to feature film and television production. With new vaults and conduit in place, substations and powerhouses readied for modification, new cable is introduced at several locations. This cable pull begins at Paramount's Marathon substation, where 3 1-million circular mill conductors, plus a 4/0 copper ground, enter the elephant's trunk to begin their run to the outlet at Powerhouse 1. At every step from feed to termination, cable is handled with utmost care. Feed reel configurations have to be versatile. The space available to accommodate feed setups varies from one location to the next, and often the space restrictions are very limiting. Because of limited space on this pole, only 3 reels could be used to supply the conductors and ground. The solution was to have the lead reel hold 2 of the 3 conductors. This cable pull was repeated several times to bring in the number of additional conductors necessary to complete this section of the electrical upgrade. An elephant trunk is positioned in this underground vault to receive 3 parallel conductors and a copper ground. The head ends are enclosed in a wire mesh pull sock to achieve a strong but flexible single unit lead through the duct. Liberal and continuous application of pulling lubricant is essential to eliminate any possibility of damage to the conductor due to friction as it moves through the conduit. With plenty of room available at the feed end, a 4-reel configuration was suggested by Keyright for the feed setup. The first reel holds the 4/0 copper ground, and reels 2 through 4 each hold a single 1 million circular mill conductor. This pull outside of Paramount's Powerhouse 2 required that 3 parallel conductors be fed from a single reel due to space restrictions imposed by nearby construction. With its 3 1 million circular mill conductors, this reel weighs in at over 10,000 pounds. The cable will be tunneling from the entry at Powerhouse 2, heading eastward into this vault and over this 90-degree pulley sheave to continue north to its termination point in an underground vault 740 feet from the feed. The process of fireproofing and splicing is meticulous. These activities demand exceptional care and patience to be completed successfully. All the concern for cable installation has to follow through during this important phase of the project. Keyright's experts in this area of work are brought in to finish the job right. Keyright offers the finest cable. But as you're seeing, the finest cable can only be as good as the expertise that is brought into all areas of the installation process. Keyright offers a comprehensive package that begins with design and ends with customer satisfaction. We don't just sell cable, we sell long-term power delivery. By using Keyright Turnkey Services, Paramount Pictures was guaranteed. Lights! Camera!
Action! Paramount Electrical Upgrade using Keyright Turnkey Services.